Welcome back to Tech Tuesday at the Allen Park Public Library. I'm Mad Dan. It is winter here in Michigan and we have a lot of experience with ice. So we're doing 3 experiments today that show different ways that ice can be manipulated. The physical world is composed of matter, and matter has 3 primary states: solids, liquids, and gases. Gases will condense into liquids. Liquids will freeze into solids, solids will melt back into the liquids, and the liquids will evaporate into gases. Using these common household items, water, salt, soup cans, and a little bit of wire, we are going to experiment with ice and water in all 3 of those phases, and stick around and find out. So our first experiment is going to be set up right now. We're going to come back to it in a little bit. So what we're doing here is we are supercooling water. Now normally water will freeze at 32 degrees Fahrenheit and become ice. However, you can supercool it under certain conditions. Those conditions are: the water has to be pure. So I have distilled water here, not tap water. Tap water has minerals and impurities that will cause it to freeze at 32 degrees the way it's supposed to. And I have salt here. Now the salt, I'm going to pour on the ice, and what that's going to do is it's going to cause the ice to melt a little bit, but because melting is caused by heat, the heat itself is coming from the ice, which is going to cool it around to much below 32 degrees. Once that happens, the water, which is nestled inside of the ice, is going to get super cooled, and as long as we don't disturb it, we should be able to do something with it at the end of the episode. So being careful not to get any of the salt in the water, we are going to pour a fair amount of salt on the ice in order to begin the melting process. If the water is higher than the ice, this will not work. We are going to take this, put it off to the side, and come back to it. So we are going to be looking at supercooling again here to explain what's happening in the first experiment. So we have 2 soup cans here, both of them filled with ice. Now I'm going to put tap water in one of the cans and salt in the other. This is Michigan, it's winter, we're in a library, there's not a lot of moisture in the air. What should happen is the tap water plus ice should cause condensation to form because it's much cooler and the moisture in the air will condense on it. The salt on the ice, because the ice is cooling from the melting action, will actually, instead of water forming, it will go straight into frost, and we'll be able to watch the frost form on the can. And we'll come back in a couple minutes. We are back at our cans. You can see the condensation on the can here. What's happening is the ice water inside is cooling the can so much that the water vapor in the air is condensing into a liquid on the side of the can. However, our saltwater can has generated a rather large ring of frost around the bottom, and that is simply from the ice needing the heat and just absorbing it, and boom, we have frost. Our last experiment is going to deal with pressure and temperature. Pressure and temperature are related. If the pressure goes up, the temperature will go up. So what we're going to do is we are going to use this weighted wire and this frozen block of ice, and we are going to let the weight of this water cut through the ice with the wire, just using the pressure. So what's going to happen is the increased pressure where the wire is touching it is going to cause the ice to melt, which then the gravity is going to pull the wire through the water to the next layer of ice, and it will keep cutting and melting as it goes all the way through. Now the weighted part of it is to cause it to happen faster, but any sort of pressure on the ice will do this. If you're walking through the driveway or if you're shoveling snow after the car has driven over it, you'll notice that it's really hard to move the tire tracks because that pressure has melted and then refrozen the snow into a harder ice to move. So this is the same thing, and we get to watch it happen. Just using pressure as a form of temperature modification, we were able to go through the ice cube. Now, this may seem like it doesn't have a whole lot of practical applications, but if you put a thin piece of metal on the bottom of, say, a boot, you create an ice skate. And the pressure of your body weight pushing down on the blade melts the ice slightly, the water's easier to glide over, and voila, you have ice skating. So, very, very cool little principle. So here is our glass of water that we have been super cooling. We've added a little bit more ice and a little bit more salt just to make sure it's a little warm in here. So we just wanted to make sure that we got it as cool as we possibly could. So let's see what happens. So we have a thermometer here. So as you can see, it is 70-ish degrees in the air. And we're going to take that and put it into our liquid water. So the water is much colder than the freezing point of water. And now we're going to see what happens when we add an ice cube to it. Oh. And our ice cube has caused a chain reaction, and the water is now much more slush than the water that it just previously was. This has been another Tech Tuesday at the Allen Park Public Library. I've been Mad Dan. These are all of the basic ingredients that you need in order to have fun with ice at home, whether it's in winter or not. So be sure to like and subscribe, and we will see you next time.